Question 1a. Complete the missing values in the triangular pattern and add the next two rows. So the way that this Pascal's triangle, the binomial triangle, the Chinese triangle, the way that it works is one row is generated from the preceding row. We can see that 2 and 1 add up to give 3. So the missing number at the top is going to be 3 as well. These two numbers add up to give the 3. It follows 1 and 3 gives 4, and if we continue that pattern, we're going to see that 3 and 3 gives 6, the 3 and the 1 gives 4. For the next row, the 1 and the 4, that's where the 5 is coming from. So in the same vein, 4 and 6 gives 10, 6 and 4 is 10, 4 and 1 is 5. Starting on the left, the 1 and the 5 give 6, 5 and 10, 15, 20, 15. And obviously we're noting a line of symmetry coming down through the middle. It wants the next two rows, so we start with a 1 on either end. 1 and 6 is 7, 6 and 15, 21, 35, symmetry. It then comes back the other way. A final row with 1s on the outside. 1 and 7 is 8, 28, 56, 70 in the middle, 56, 21 and 7, 28, 8. B1. An unbiased coin will be thrown 3 times. Complete the table to illustrate all 8. We're looking for 8 possible outcomes. We have our 8 outcomes listed here, 1, 2, 3, 4, 5, 6, 7, 8. We're looking for a logical, systematic way of writing it out. So we could have a heads for the first throw, and then the second throw is heads and the third throw is heads, or we could have heads and then tails, or heads and then tails and then heads, or heads and then tails and then tails. Or instead of heads followed by this pattern, we could have tails followed by the same pattern. Heads, 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 tails, tails, heads, tails, tails. There are 8 possible outcomes. Number 2. Which of the outcomes match the statement exactly 2 heads are seen? The top one is 3 heads, but this number 2, there are 2 heads, there are 2 heads here, and there are 2 heads here. So that is number 2, number 3, and number 5. Those 3 outcomes, each one is there are 2 heads. Which of the outcomes match 1 head is seen? We can see 1 head here, here, and here. So 1 head is number 4, number 6, and number 7. Into the table below, use the table to summarize these 8 outcomes. So whilst we've got 8 outcomes, if we were to describe them as 3 tails, in other words, no heads, 2 tails and 1 head, 1 tail and 2 heads, no tails and 3 heads. When we look at this one, 2 heads, 2, 3 and 5, we can see that 2 heads is 3 ways. There are 3 outcomes like that. We also worked out that for 1 head, 2 tails and 1 head, that was those. So we have 3 here. How many ways can you get 3 tails? 3 tails is just that one. 3 heads is just that one. So 1 of those and 1 of those. And then matches 1, add 3, add 3, add 1. That's 8. Part 5. Find the probability that the coin will land on tails at least once. At least once is there, there, and there. It is not the far right, no tails, but all the others. So out of every 8, 7 times out of every 8. If we want a decimal, 7 divided by 8, and we get 0.875. Okay.